Now we're going to look at a few maps of the body that correspond to your spinal nerves. This first one is a dermatome. Think of derm means skin. So this is showing areas of skin, and if you look at the labels on these areas of skin, they might look familiar, like T2, T1, L2, L3, L4. Those are the names of spinal nerves. So a dermatome is a map of the skin that shows which spinal nerve innervates each area of skin. And this is useful for assessing damage. You may have seen, or it may have happened to you, like you're in an accident and your back might be hurt, and they might poke you right here on your leg and say, can you feel that? And if you can't feel that, then you might have damage at the L4 spinal nerve. Or maybe if your fingers are numb, you might have damage at C8 or C7. So this is helpful for knowing which spinal nerve goes where, and that can help you check those spinal nerves. Another thing that can happen is phantom pain. This is when a person can feel pain in a body part that is no longer there. So this is common for people who have had an amputation. So if you think about those sensory neurons, remember the primary sensory neuron would come up, you would have that axon comes all the way up, it goes into the posterior root, and you have the cell body in that posterior root ganglion. So this is our primary sensory neuron, and it has its cell body in the posterior root ganglion, which remember is right next to the spine. And then there it connects with the secondary, which goes up to the thalamus, and then from there, the tertiary, which goes up to the somatosensory cortex. So here is your somatosensory cortex on the parietal lobe. And remember, it has a map of the body. So right here, it has a section dedicated to the foot. Now, if you get an amputation, so in this picture, the person's leg has been amputated, and it shows that they're still feeling pain in the foot. When you get an amputation, you cut off the axon of that primary sensory neuron. But as long as the cell body of a neuron is alive, then the neuron is still alive. So the cell body of this neuron is still alive in that posterior root ganglion next to the spine. Now also, when you get an amputation, Your somatosensory cortex does not know about that. So here, the somatosensory cortex with the map of the body does not know that that body part has been amputated. So as far as it's concerned, you still have a foot because it still has a foot on its map. So then you can still get signals going up that pathway and to that spot on the map. So because this cell body is still alive, it can still send signals to your somatosensory cortex. And your somatosensory cortex has no idea that you don't have a foot anymore. It gets those signals go to its spot on its map where the foot is, and it feels pain in the foot. And this pain is just as real as the pain from somebody who does still have their foot. The brain, the part of the brain that feels pain, doesn't know the foot isn't there. So the pain is just as intense and just as real as if you did have a foot that was being injured. Another thing that can happen with pain is referred pain. Your internal organs share sensory pathways with areas of skin. A common example is pain in the left arm during a heart attack. A lot of people know to watch for that as a symptom of a heart attack. So if we look at this picture, here's your heart, and you can see here's its neuron. Sensory neuron comes in, you go through the posterior root, there's the cell body in the posterior root ganglion, and you go to the posterior horn in the spine. Here is the skin of the left arm. Its axon comes in, goes into that same posterior root, has its cell body in that ganglion, goes in to the posterior horn in the spine. Notice there's only one neuron here. They both synapse onto that same neuron, and this is the neuron that goes up to your brain. So whenever the skin is hurt and it sends a signal, your brain gets the signal from the skin on this neuron. When your heart is hurt and it sends a signal up to your brain, it's the same neuron that carries the heart signal. So when your brain gets the signal, it's not entirely sure if it came from the skin of your left arm or your heart, because they both share the pathway. So your brain can't distinguish which sent the signal. And most often, when your brain gets a signal from an internal organ, it will assume that your skin sent it. Your skin has been sending pain signals your whole life, ever since you were a baby. Not very often does an internal organ send a pain signal. So your brain is used to your skin being the one that sends these signals. So your brain will assume that your skin sent the signal. So, although pain in the left arm is a common sign of a heart attack, There's actually nothing wrong with the left arm. You're having a heart attack, your left arm is perfectly fine. It's not actually sending a pain signal. It's just kind of been framed for sending a pain signal. So there is nothing wrong with the skin. It is kind of falsely accused of being in pain, or it's been framed. But knowing this is helpful to diagnosing problems. So we know which areas of the skin share pathways with which organs, and we can use that to help diagnose problems. So again, with the heart attack example, everybody knows that the left arm is a sign of heart attack. Another example, if you look here, the liver and gallbladder, and that goes around onto the back there also. So for example, I once had some trouble with my gallbladder, and every time I ate, I would get this stabbing pain in my shoulder blade. So I went to the doctor, and all I said was, every time I eat, I get this horrible stabbing pain in my shoulder blade. And immediately my doctor said, oh, it's probably your gallbladder. Another example is the appendix. If your belly button hurts, that's a sign of appendicitis. So knowing these areas of pain can help you figure out which organ is having a problem.